So next we have an interesting technology. I think continuing the trend of observability as well. How many of you are familiar with Thanos? Which one, the Marvel character or? Okay. Okay, so I'm welcoming Aditya Joshi. He is a software engineer at Walmart. And Aditya will delve into the transformative power of Thanos and help us and get a better understanding of the technology. Over to you, Aditya.
Okay, I think yeah, all set. Okay, so I'll start with my introduction. Hi everyone, I am Aditya. I work at Walmart in our platform engineering team, and I'm a software engineer in my platform team. And I am an instructor at Udemy as well. I have a bunch of courses around the blockchain technology, and today I'll be talking about how you can have or how you can run monitoring at a scale in a Kubernetes environment, right? So just a question: how many of you are familiar with Prometheus, and how many of you are actually running Prometheus in your production environments? Okay, I can see a few hands. And okay, so today we'll talk about how you can run Prometheus at a scale, and we know that there are shortcomings of the Prometheus, and we'll try to see how we can come up with the shortcomings and build something scalable for your monitoring stack. So just FYI agenda here, what we'll be covering today, we'll covering what is Prometheus, just an overview of Prometheus, running Prometheus at scale, what all challenges you can face when you are actually running up the Prometheus, and then to rescue us, there will be a Prometheus that will be coming us to rescue. We'll try to solve those problems that we were having with the Prometheus and try to make our solutions scalable, and then then there will be final Q&A talk. Okay, so what Prometheus is? So Prometheus is, few of might be knowing that Prometheus is a tool using which you can collect matrices from the systems, right? And you can use those matrices to build the alert so that whenever something goes wrong, you get notified on the runtime. So Prometheus is just a tool, and it has a few other components like the time series database, which is a database that stores all those matrices that your application is generating. And Prometheus has something called as scraping, which is an engine or the core of the Prometheus that scrape those matrices from your services and pushes that to its time series database, and from there you can integrate with other tools like Grafana to visualize those matrices or how your application is actually performing. And it also provides you a PromQL language using which you can query those matrices. So it's similar to you have SQL languages for relational databases, but in Prometheus you have something called as PromQL using which you can query the matrices, how your systems are performing or whether if there is anything going bad with the system or not. So this is a functional view of what all components we have in a Prometheus, right? We have the core engine Prometheus, then you have a query engine using which you can query all the matrices, then you have a scrape engine which is scraping the matrices from the services, and these services can be running anywhere. This doesn't have to be necessary in the Kubernetes, they can run in any VM or they can run local in your machines as well. All you have to do is you have to provide the right set of configuration so that Prometheus can reach out to these services and can start streaming the matrices. Then you have a rules and alert engine. Basically, with the help of this particular engine, you can set up alerting on the top of your matrices. Let's say you want to have an alert saying that, okay, whenever you have a resource, let's say, and whenever the resource is consuming, let's say 80% of the CPU, then you want to get alerted and you want to maybe increase the CPU, or maybe the same can be applied for the disk or for the memory consumptions as well. So this is a bare minimal setup, how generally we run Prometheus in a Kubernetes cluster. So you will be having a Kubernetes cluster where you have a Grafana that is running to visualize the matrices, and then you have Prometheus as well, using which you are collecting the matrices and then using Grafana to show all those matrices in the UI, right? And simply user is going to use PromQL to query all the matrices if you want to see something. Even the Grafana is also using those PromQL queries to render all those graphs and charts, right? So this is a very minimal setup, works very file, you have Prometheus, Grafana, and a bunch of exporter that you want to use in order to transform your application specific matrices maybe to Prometheus. But the problem comes when you want to run Prometheus at scale, and there are a lot of challenges when you are actually, running Prometheus at scale. You want to have high availability, you want to have a long-term storage. And what we expect as a user of the Prometheus, we have some expectation from the Prometheus that we want to, when we want to have a highly scalable system, these are some of the expectations, right? We want to have a global query view, and which means that, you should be able to query multiple Prometheus from a single or from a centralized store, right? We want to have long-term storage as well, because whenever we configure Prometheus, we used to set up a retention policy of the matrices. So let's say 30 days is a retention policy, which means that your matrices will be there with the Prometheus for 30 days. But what after 30 days, right? Let's say you want to query the matrices of, let's say, last 6 months, and you want to analyze a trend, that what's the actual consumption, or how your application is performing over a period of time. Again, that thing you cannot do because of the limitation in the Prometheus, right? And we always know that, storage is costly. The object storage is slightly cheaper, but the blob storage and all these storage are, volumes are quite costly. And in order to, run Prometheus at scale, we cannot store all the data in these, storage. So we want to have a cheaper way where we want to store these matrices. And object storage and S3 storage is, a very good way where you can store the matrices at a, cost-efficient manner. We also want to downsample the data, and what downsampling means is basically you want to, shrink the data. Let's say you have a data of over 6 months or 6 months, and you want to, just downsample the data to 1 month, let's say. So downsampling is also needed, and that will, somehow reduce your matrices. But again, you will be able to see the entire data or the trend over the period of time. So when we want to run Prometheus at scale, there are a couple of approaches that you can use, and that I also have tried on my personal, and I'll be sharing those approaches and the shortcomings of those approaches as well. So the first approach that we can have is, so if you have multiple clusters, where you are running Prometheus, you want to have something somewhere, some component which is managing all these Prometheus, so that that's how you are able to store matrices at some centralized place, right? And to solve this problem, we have something called as federation in Kubernetes. What this allows you is basically you can have a central Prometheus server which is connected to downstream Prometheus server, and it's scraping those matrices from the server. So if you run a single instance of the Prometheus servers, what it actually does is it's going to scrape the matrices. But in case of federation, how it's happening actually is that now the central Prometheus is actually scraping up your downstream Prometheus server. So your downstream Prometheus servers, they will be scraping the matrices from the services, they will be storing those matrices for some time, and then those matrices will be scraped by the centralized Prometheus. And then you can have a Grafana on the top of the central cluster, and then from there you can visualize the matrices. Now this is a good approach to start with, but again this has some shortcomings as well. So when you have too much of such cluster, right, then it becomes quite difficult to manage these clusters, because every time when you add a new cluster to this kind of a setup, you have to do the configuration update, right? And scaling becomes quite difficult in this case, because now you have to manage all these clusters, and then you have to also look on the data part, because now so far we are just talking about mainly on the HA high availability part, but data part we have not considered yet, that how we want to store the data. If you want to store the data for a long duration of time, then how we are going to do the downsampling, and do we actually want to store the data into these object storage, or maybe we want to use the old traditional ways of having the disk where we want to store the data. And again, there can be another problem, that the very last problem that I mentioned is the scraping interval, because every server that is, or every cluster that is running, they might be meant for different use case, right? You might be solving some different use cases on these clusters. So every cluster might have its own, scrape interval, and then you have to fine tune the right value for that particular scrape interval in order to, achieve this kind of a setup. Now, there can be another approach as well to solve the same problem. The another approach could be that instead of, there is central Prometheus which is scraping all these matrices, then can be some other Prometheus instance to which all these Prometheus instances are sending all those data, right? So this is called remote write approach, and basically in Prometheus there is a remote write API available. You will have to just enable that API, and then you can start, pointing to the central Prometheus, and then downstream Prometheus can, start pushing up those matrices to the central Prometheus. So in this case as well, now we don't have to deal with much configuration at the central level, because in the previous example that we saw, the federation based approach, where all the configuration was kept at a centralized server. So every time if you add a new cluster to it, you have to modify the central configuration. But here you will be just updating the configuration of the downstream clusters, and let's say tomorrow you want to add, let's say, one more cluster, you will be just updating the endpoint in the downstream cluster and just pointing it to the central cluster, and that way you will have same kind of features, like the Grafana will be there in the central cluster, and from there you can visualize all the matrices coming to this. Now we still have we still have those problems, like we didn't talk about. Right now we are just talking about the high availability part. How we can have availability of multiple clusters, like how we can have data in a centralized cluster, right? We didn't talk much on the data part. How we want to solve the problem of the data, or the long-term storage, so to say. But let's talk about the high availability part. So in order to run multiple instances of the Prometheus in a single cluster, then that can solve the problem of high availability, because now you have multiple Prometheus servers scraping up same service twice, because now you have two Prometheus server and then you have the matrices. But then also it brings more problems, because now you have a problem of duplication metrics. Like your metrics are kind of duplicated, because now you have two Prometheus instances capturing up the same matrix, and then you are storing up those same matrices to somewhere, maybe in disk or maybe to some upstream servers. The problem still persists there, and there can be another approach where you run Prometheus in a namespace based, right? So let's say for every namespace you end up having separate Prometheus instance which is looking for that particular resources or objects that are in that particular namespace, just watching this and generating up the matrices. Again, the problem still remains same, because there can be chances of having the drift in the matrices, and there can be a chance of duplication of those matrices. Now, in the other challenge that I just want to talk about is the long-term storage challenge, because in Prometheus or in any monitoring environment, we want to have the previous matrices as well, the older matrices as well. And why we need this? Because these matrices can help in identifying or coming up with the estimation for the future requirements as well. That if you are seeing some trend over your past matrices, then you can take a better decision. And like I told that disks are always they are very costly in storing up these matrices. So we want to have a cheaper way, and object storage or S3 can be a cheaper way to store these matrices. Again, these things are right now not supported by the Prometheus out of the box, and we need some help in order to solve these challenges. And in order to solve these challenges, there comes Thanos. So Thanos is basically a tool. It's an extension to the Prometheus. So it works on the top of the Prometheus. You cannot run Thanos just alone. It needs some Prometheus in this, and it works on the top of those Prometheus servers. So Thanos provides you a set of components, and these components can work independently. I'll show you, in the coming up slide, all those components. But these components are, they can work independently. So it has components like sidecar, then querier. All these components can work independently, and it just needs a data source from where it can, pull the matrices, and you can take actions on the top of those matrices. So the main goal of the Thanos is to achieve all the problems that we were facing with the Thanos. One was to have a global query view, and this basically means that you want a centralized place from where you can query all the matrices just from a unified way. The second thing is retention, because with Prometheus, whenever you set up a Prometheus, there is a default retention policy, and we are not happy with the retention policy, because if we try to update those retention policies, then we'll end up in spending up so much cost on the storage part, right? It's fully compatible with the Prometheus, and it provides downsampling and the compaction as well. So you can compact your matrices as well with the help of Thanos. There is a Thanos component called Thanos Compactor, which allows you to downsample all the matrices that you have. So these are some of the components that are available in the Thanos. So one of the component is sidecar, and the name suggests sidecar, which means that it must be running somewhere as a sidecar to some container. And sidecar runs next to the Prometheus. So wherever you are running a Prometheus server, you will be just adding one more container next to the Prometheus, which is sidecar, and then sidecar will be collecting all the metrics from the Prometheus, and then you can Prometheus can simply Thanos can simply, use that sidecar and, ship the matrices to the Thanos server. The other component that we have is the receiver, and receiver works in a reverse way. Initially we saw two approaches. One was the federation, and second one was the remote write. So same kind of concepts are applied here as well when we talk about sidecar and the receiver approach. So in sidecar, what happens is that there will be a central Thanos server, which is pulling all the matrices from the sidecars. But in case of receiver, it's the reverse process where receivers are kind of pushing those, or all the downstream Prometheus are pushing the matrices to the receiver, and then from receiver, Thanos can reach out to the receiver and start consuming the matrix from there. Then we have other components like store gateway, which helps connecting with the storage, and then we have a ruler to set up the rules. Then we have a compactor to compact all those matrices, and then we have a querier to query all these matrices. And this querier components allows you to get a unified view from, or the global query view from where you can query all the downstream data sources. So let's talk about sidecar in much more detail. And in my presentation, you will find a lot of such diagrams that I have kept that will help you in understanding all these components in a better way. So in case of sidecar, now if you try to compare the same approach with the federation-based approach that we saw previously, we used to have centralized Prometheus, and then there were some downstream Prometheus server. Centralized Prometheus server was reaching out to all the downstream Prometheus server and scraping on the matrices. Similar approaches here as well. And what additionally we see here, that there is no, along with the Prometheus server, there is one more container that is running, that is sidecar. And you can run it either in the form of a sidecar container, or it can be an independent deployment or a pod itself as well. At the end of the day, sidecar needs it needs the communication to be set up with the Prometheus server so that it can pull the matrices and start giving it to the upstream services as well. So here we can see that in this particular diagram that we have multiple clusters, and next to every Prometheus instance in these clusters there is a sidecar running, and then there is a object storage as well, if you see. And Thanos, like I told, that Thanos provides you a compatibility with the storage as well, like the object storage, so you can push these matrices to the object storage. And in this particular reference diagram that we see, that sidecar can push these matrices to the storage as well. So you can push these matrices to the object storage, and from there you can start reading of the matrices as well. So there is an API called Store API, and it's a interface written in the Golang. So with the help of this particular interface, the querier can simply write the matrices to object storage. And then you can have Grafana, which is using querier to query the matrices, and your matrices can either present in the they can be either in the object storage, or they can be coming directly from the sidecar as well. So if you see, there is a demarcation that is made that your matrices can be either coming from the object storage as well, or they can be coming from the downstream sidecar as well, again with the help of querier. So querier is responsible for pulling or getting the matrices from either from the object storage or from the sidecar as well. Now the next approach is similar to remote write approach. It's a receiver based approach, and I call it as a pull based approach, because here now the matrices will be kind of pulled. And here you can see that the directions are slightly reversed here. So we have a component, something called as Thanos receiver, and now all the Prometheus instances are pushing to this receiver. So they are using the same remote write API to push the matrices, and from there again these matrices can be stored by the receiver to the object storage. And when you are trying to query these matrices, they can be queried either through the receiver directly, or they can be queried directly through the object storage. Okay, let's talk about one more component, which is Store Gateway. And Store Gateway basically helps you in storing up all these matrices to the object storage. So there is a component, Store Gateway, using which you can either store the matrices, and you can retrieve the matrices as well with the help of Store Gateway. By the way, like, any questions so far with all these components? Okay, there is one, I guess.
Hi, I'm Guna. I just wanted to know, can we configure alerts for Thanos? can we configure?
Right. So that's an interesting question. I thought of taking it at the end, but okay. So usually when we set up we usually set the alerts in the Prometheus server, like very near to the Prometheus server. In Thanos as well, there is a rule engine that is provided using which you can set the alert. Now the major question here is that where to set those alerts, like to the actual Prometheus server, like near to the Prometheus server, or to the Thanos. Now, when we were, when I was just reading about Thanos, and where to actually configure these alerts. So, so you have to define your alerts, like what kind of a priority these alerts have. If these alerts are quite critical to you, right, then you want to configure them near to the Prometheus, like at the Prometheus level itself. But if these alerts doesn't have that criticality, then you can configure them at the Thanos level as well, because there is always a latency that is coming from the downstream to the upstream. So that way you will not miss those critical alerts. But if your question is if you can configure alerts in the Prometheus, then yes, in the Thanos, then yes, you can configure alerts.
Thank you.
Okay, so we were trying to solve few problems, right? One was the object storage, and second one was the HA part, or the long-term storage, right? So now we were able to store the problem of the storage part, at least, because now we can store the matrices in object storage, which is quite cheaper, and now we know that we can query these matrices as well on the runtime with the help of store gateway as well. Right, and we also want to compact the matrices as well, so that we don't end up in again in the same problem where we have now huge volume of the matrices, and then we are querying all on the bunch of those matrices, like the millions of matrices, and then it's quite slow in that nature. And that is where you can use compactor. And compactor is basically directly attached to your object storage, where it can compact your matrices always. So when it's a background job that is attached to your object storage, and then it will on the background it will try to compact the matrices as per the configuration that you want to define. And you can define like at what should be the compaction rate as well, that can be defined in the compactor configuration. Now, to make your storage, highly available or too redundant, so to say, you can use one more component that comes with the Thanos, which is replicate. And replicate allows you to, replicate your object storage as well. So there will for a replicate component, the input source can be your one object storage, and the destination can be the other object storage. Now, with the help of this replicate component, you can always, replicate the data from one region to another region. Maybe if you want to have, you want to make the storage as well HA, or you don't want to, you want to keep them into different zones as well. Again, you can do with the help of replicate component. And these components, all these components that we are seeing, they can work independently as well. So if you don't want to use replicate, then you can use a normal setup with the sidecar, or either through the receiver approach, and you can use maybe store APIs to store or to basically read and write from the Prometheus server. Okay, so this is the part where we can set up the alerts on the top of Thanos as well. So we know that in Prometheus we can set the alerts by if you have used Prometheus operator, then there is a custom resource called, I think it's rules. So you can use that rules CRD to generate or create the alerts. But in Thanos as well, you can define the rules. And again, the rules are going to be the same rules how you define the Prometheus, because it's built on the top of Prometheus, like taking the inspiration from the Prometheus, and then these components are built. And the query language will, again, it's going to be the same query language like the PromQL, and you can write the rules based on your requirement. Okay, now let's talk about a high availability part. Okay, so the problem of the object storage or the long-term storage we were able to solve by using Thanos with the help of store gateway, because now we have the matrices available. But the other problem, which was the high availability, like how we can ensure that the data is kind of always available. So in Prometheus as well, what happens is that Prometheus is always going to retain up the data till the retention policy, and when the retention policy is kind of met, then it will start deleting up the data from its storage. Now, in order to solve this problem, we we have something called as querier. It's a tool using which you can query the matrices. And now we don't have a single query interface. Rather, we have multiple querying interface, or these tools, multiple query instances, which are running in conjunction, and then they are capturing up the matrices from the sidecars as well. So this way, like, you can have the high availability setup in the Thanos environment. And let's talk, let's take a different illustrations to this. Like, that was a very simple scenario that we saw. This is a bit different, where now you have multiple instances of the Prometheus as well, and now you still want to have high availability. In this case, we can have multiple instances of the Prometheus. Again, there will be, we know that there is a problem of duplication of the matrices, and Thanos sidecar knows how to resolve these deduplication, so that can be possible. And then you have a query component which is talking to these sidecars individually, and then giving up the data. So the deduplication will be handled by the query itself. So query component is going to deduplicate your data, and then it's going to give you the actual data only. Now there is, now to make it, so if you see the last two diagrams, we are just making some extension to the existing architecture reference, and we are trying to solve simple problems by adding few components, right? So if you see this component, so now we have slightly changed the architecture, and now here along with all those sidecars, we have now the query deployed at every cluster level itself. So now your query becomes a bit faster, because now you have a component called query, and so your central Prometheus server or the query instances is going to reach out to these query components at the cluster level, and then they are going to do the deduplication itself. So now the deduplication happening at this level itself, and now the central query component doesn't have to do lot of work, because it's getting the data from the query components, and it's simply going to show you the data. So that piece of kind of is resolved at the individual by the individual query component. Okay, so so here I just want to talk about the scalability aspect. If we look at this, right, so where we were talking about the sidecars kind of pushing the matrices to somewhere, and it may explode as well when you have so much clusters, and they are hitting up some central storage, and there will be too much request, right? Now in order to solve this, we have we can leverage receiver. So receiver is meant to receive all the matrices, and then you can have multiple instances of these receivers as well. And when you have multiple instances of the receiver, there is you want to have orchestration between these receivers as well, because now when you deal with the stateful data, you always need an orchestrator, because you are not sure which data is correct, right? The data that is received by receiver 1, whether that data needs to be replicated to other receivers or not. So all those things are taken care by the they're basically taken by the query itself. Sorry, they are taken by there is something called as hashing, which we typically use in the distributed systems, where every instance of the receiver that is there, it basically there is a hashing formed between all these components, and whenever a addition or a removal of these receiver happens, that happens via the help of hashing. So hashing kind of maintains all the list of all the receivers that are currently active, and it's going to choose one of the leader from that, and it's going to whatever that leader is saying, it takes that as a reference, and then distribute the data based on what leader is saying. So my final slide. So this is how you can have this is the same functional view that we saw initially, but this is where when Thanos or Prometheus finally met Thanos, where now you have a same set of services, but you have a Prometheus as well, which is receiving the matrices or capturing the matrices from the different Kubernetes services or some VMs as well. And now the Prometheus sending those matrices to the sidecar, or they are captured by the receiver as well. And then underneath there is a storage now you have available, which is S3 storage or the object storage available. You can use compactor and the store APIs to store the data. and you compact it to compact the data, and then you can have a query which can be attached directly with the sidecar or the receiver just to query up the data. And then you have rules which is built on the top of alert manager. So now you get the same set of features that are available in the alert manager, and you can create those rules and get alerted whenever there is something bad with your cluster. So yeah, that's all I have for today. And if you want to reach out to me, then these are my social media handles. Thank you.